The Deutz MAH711 stationary engine is a classic example of German engineering from the mid-20th century, widely recognized for its reliability, simplicity, and robust construction. Manufactured by Deutz AG, one of the oldest engine companies in the world, the MAH711 belongs to the renowned MAH series, which gained popularity across Europe and beyond for powering agricultural, industrial, and auxiliary applications.
Der läuft! Ja, geil.
This engine is a single-cylinder, four-stroke diesel unit, water-cooled, and designed to run at relatively low speeds, which contributed to its longevity. With a displacement of around 1.5 liters, the MAH711 typically produced about 10 to 12 horsepower, sufficient for operating threshing machines, mills, saws, generators, and irrigation pumps. Its simplicity in design, including mechanical fuel injection and minimal electrical components, made it easy to maintain and repair, even in remote rural settings. A notable feature of the Deutz MAH711 is its characteristic flywheel, which ensured smooth operation and efficient energy transfer to belt-driven equipment. Its slow-running nature also made it fuel-efficient and capable of running for extended periods with minimal wear. Farmers and workshop owners valued the MAH711 for its dependability, particularly in an era when electricity and modern engines were not yet universally available. Today, the Deutz MAH711 is considered a collector's item and is often restored by enthusiasts who display it at vintage engine rallies. It stands as a testament to the durability of early stationary engines and the lasting legacy of Deutz in the development of practical, hard-working diesel power units. After standing still for nearly 17 years, the GHHLF8, equipped with a Deutz F6L913 engine, finally roared back to life. This vehicle, once used as a reliable fire engine, carries both historical and mechanical significance. The Deutz F6L913, an air-cooled 12-cylinder diesel engine, is known for its durability and distinctive sound. Bringing it back into operation after such a long pause required patience, care, and respect for the machine's legacy. The first start was not only a technical achievement, but also a tribute to the engineering quality that allowed this classic powerhouse to awaken after nearly 2 decades. The Detroit Diesel 6-53T is part of the well-known Detroit Diesel Series 53 family, a line of 2-stroke diesel engines developed in the mid-20th century and widely used in industrial, marine, and military applications. The 6-53 designation refers to 6 cylinders, with each cylinder displacing 53 cubic inches, resulting in a total displacement of 318 cubic inches, about 5.2 liters. The T suffix denotes the addition of a turbocharger, which boosts power output and improves overall efficiency compared to its naturally aspirated counterpart. Like other Detroit diesel 2-stroke engines, the 6-53T uses a uniflow scavenging system with a roots blower to assist in air delivery. The turbocharger enhances this system by increasing air pressure, allowing for higher fuel injection rates and greater horsepower. Depending on configuration, the 6-53T could produce around 200 to 275 horsepower, with torque characteristics well suited for heavy-duty work. The engine gained popularity in a variety of applications, including construction machinery, trucks, buses, and boats. Its compact design, reliability, and ease of maintenance made it a favorite in demanding environments. The modular nature of the Detroit diesel design also allowed for relatively straightforward servicing and parts interchangeability. However, like many two-stroke diesels, the 6-53T had drawbacks. It was known for being noisy, consuming more fuel and oil compared to modern four-stroke designs, and producing visible exhaust smoke. Despite these limitations, the 6-53T remains a respected engine among enthusiasts and operators, representing an era when durability and simplicity were the hallmark of Detroit diesel engineering. The Fairbanks Morse 15 HP special electric engine was a robust, stationary power unit widely used in the early 20th century for industrial, agricultural, and municipal applications. Designed for reliability, it provided consistent 15 horsepower output, ideal for running pumps, generators, and heavy machinery. Unlike smaller farm engines, the special electric model was built on a larger, heavier frame with precision engineering to ensure durability under continuous operation. It featured a magneto-ignition system, water cooling, and heavy flywheels to maintain steady power delivery. Favored for its adaptability, the 15 HP Special Electric could operate in factories, mills, or rural installations, making it a versatile choice. Its reputation for ruggedness and long service life solidified Fairbanks Morse as a trusted engine manufacturer. The 50 HP Fairbanks diesel was a rugged, medium-sized stationary engine built for continuous duty in industrial and agricultural settings. Manufactured by Fairbanks Morse, a company renowned for its dependable heavy machinery, this engine represented a balance of compact size and reliable horsepower. Rated at 50 horsepower, it was powerful enough to run pumps, generators, sawmills, or small plant equipment, yet efficient compared to larger diesels. Fairbanks Morse emphasized durability, with heavy cast iron construction, robust bearings, and a simple fuel system designed for long service life. Many units operated in remote areas where reliability was critical, earning a reputation for steady performance under demanding conditions. Today, collectors and enthusiasts value surviving 50 HP Fairbanks diesels as icons of early 20th century American engineering, often restoring them for display at engine shows. The Fairbanks Morse 15-25 tractor, introduced in 1910, marked the company's first real step into the competitive tractor market. At the time, farmers were demanding reliable, large-scale power for breaking virgin soil and working expansive fields, and distillate-fueled tractors were becoming the preferred solution. Fairbanks Morse, already a trusted name in stationary engines, adapted its proven 25 horsepower NB engine for tractor use. This decision mirrored International Harvester's earlier strategy of modifying their well-known famous stationary engines for mobile farm work. The 15-25 was rated at 15 horsepower on the drawbar and 25 on the belt, making it a capable machine for both plowing and powering threshers or sawmills. Mounted on a robust steel frame, it carried the durability and reliability for which Fairbanks engines were known. Farmers appreciated the engine's steady performance, particularly its ability to run on low-cost fuels like kerosene and distillate, keeping operational costs manageable. Though the 15-25 was not produced in the same large numbers as some of its competitors, it demonstrated Fairbanks Morse's ability to transition from stationary to mobile power applications. Its introduction helped establish the company's foothold in agricultural machinery, laying the groundwork for future tractor development and further blending engine expertise with practical farm innovation. This nice old tractor, a Caterpillar D6 with serial number 9U17, had been sitting quietly outside beside its previous owner's garage for the last 18 years. Weathered by time, its yellow paint had faded, and a thin layer of rust hinted at long seasons of rain and sun. For nearly 2 decades, the machine had stood still, a reminder of the hard work it once performed. When the time finally came to bring it back to life, there was both excitement and uncertainty. Would the old cat turn over after such a long rest? After fresh fuel, new batteries, and a careful check of fluids, the switch was thrown. With a cough, a puff of smoke, and a deep growl, the D6 came alive again. The sound of its diesel engine, after all those years, was nothing short of remarkable, a true testament to Caterpillar's durability and the spirit of old iron. A miniature steam traction engine powering a can crusher is a fine example of steam engineering put to practical use. Once fired up, the little engine steams smoothly and happily holds 50 psi, providing a steady, reliable output.
Never leave home without it.
Despite its small scale, it has plenty of torque, more than enough to drive the crusher's mechanism with ease. The rhythmic chuff of the exhaust and the gentle hiss of steam add character as it works away, flattening cans effortlessly. Compact yet capable, it demonstrates how even a model traction engine can deliver real mechanical power. Built for long runs, it will happily operate all day, making both an entertaining and effective setup for hobbyists and steam enthusiasts alike. The Holt 75, developed by Holt Manufacturing Company in the early 20th century, was a powerful gasoline-powered crawler tractor, widely recognized for its role in both agriculture and military applications. By the time it reached late production in Stockton, California, the Holt 75 had become a refined and reliable workhorse. It was equipped with a 4-cylinder engine producing around 75 horsepower, designed to handle heavy plowing, hauling, and construction duties. Its crawler tracks, an innovation pioneered by Holt, allowed it to operate effectively on soft or uneven ground where wheeled tractors struggle. During World War I, the Holt 75 was adapted for military logistics, towing artillery and supplies across muddy battlefields. In Stockton's late production period, improvements in durability and performance cemented its reputation as one of the most versatile tractors of its era. The Holt 75 laid important groundwork for what would eventually become the Caterpillar Tractor Company. The Detroit Diesel 6 V53 is a two-stroke diesel engine that became a workhorse in a wide variety of applications during the mid-20th century. Part of the Detroit Diesel Series 53 family, the 6 V53 is a V6 configuration engine with 6 cylinders, each displacing 53 cubic inches, for a total displacement of 318 cubic inches, 5.2 liters. Known for its rugged design and distinctive high-pitched Detroit scream, the 6 V53 earned a reputation for reliability and durability in demanding environments. This engine was widely used in military vehicles, including armored personnel carriers and trucks, where its compact size and dependable power delivery were valuable assets. It also found roles in construction equipment, buses, boats, and stationary machinery. The two-stroke design, featuring a roots blower for scavenging, allowed the 6V 53 to deliver strong performance relative to its displacement while maintaining simplicity in construction. Though fuel efficiency was not its strongest trait compared to modern four-stroke diesels, the 6 V53 was prized for its ease of maintenance and ability to operate in harsh conditions. Today, it remains an iconic engine among enthusiasts, remembered as a symbol of Detroit diesel engineering and a mainstay in both military and industrial history. The Deutz BF4L913 is a robust, air-cooled, four-cylinder diesel engine, widely used in construction, agricultural, and industrial machinery. Repairing this engine requires careful attention to its unique design features, such as air cooling, direct fuel injection, and its durable cylinder liners. Common repair tasks include overhauling the fuel injection system, replacing worn pistons or piston rings, inspecting the turbocharger, if equipped, and checking valve clearances. Since cooling relies solely on airflow, cleaning the cooling fins and ensuring proper fan operation are critical to prevent overheating. During disassembly, mechanics should mark and align components precisely to maintain timing and balance. Genuine Deutz parts are recommended for longevity and performance. After reassembly, proper torque settings and systematic testing under load ensure reliability. With correct maintenance and timely repairs, the BF4L913 continues to deliver dependable power in demanding environments. The 8-horsepower Bessemer engine was a small but durable internal combustion engine produced in the late 19th and early 20th centuries by the Bessemer Gas Engine Company of Grove City, Pennsylvania. Bessemer was a leading name in early American engine manufacturing, best known for its large stationary natural gas engines that powered oil fields, factories, and pumping stations. The 8-horsepower model represented one of the company's smaller offerings, designed for farms, workshops, and light industrial use. Like its larger counterparts, it typically ran on natural gas or producer gas, although some versions could operate on gasoline. It was a single-cylinder, horizontal engine with a heavy flywheel to ensure smooth, steady operation. Owners value the 8-horsepower Bessemer for its rugged construction, reliability, and ability to run continuously with minimal maintenance. It provided enough power to operate threshing machines, pumps, saws, and other essential equipment in rural communities. Many were mounted on skids or small trucks, so they could be moved between job sites. Today, surviving examples are prized by collectors and engine enthusiasts. Restored 8-horsepower Bessemer engines are often displayed at antique engine shows, where their rhythmic exhaust and massive flywheels evoke the ingenuity of America's early power age. The MAN D2676 engine is a 12.4-liter, 6-cylinder inline diesel engine widely used in trucks, buses, and marine applications. Renowned for its durability and fuel efficiency, it delivers high torque and power output with low emissions. Featuring advanced common rail fuel injection, turbocharging, and optimized cooling, the D2676 ensures reliable performance even under heavy loads. Its design emphasizes reduced operating costs, long service life, and compliance with strict emission standards. The beautiful Gardner 3LW had its test run at Walsh's in Stretton, Manchester, following a careful rebuild. Soon to be installed in my boat, the engine ran smoothly and sounded fantastic, proving its legendary reliability. It's now just waiting on the final touches, with pipes and parts due to be polished or chromed. Exciting times ahead as this classic powerhouse gets ready for a new chapter on the water. The Deutz F1L514 first startup after restoration is a rewarding moment, showcasing the timeless durability of this classic single-cylinder diesel tractor. With its air-cooled engine freshly serviced, the distinctive clatter and steady rhythm return, echoing its post-war heritage. Watching smoke clear as the machine settles into a confident idle reflects both the precision of Deutz engineering and the dedication of restorers. It's not just an engine running, it's history brought back to life. The 1936 Caterpillar Citrus 22 was a small, specialized crawler tractor designed to meet the needs of orchardists and citrus growers during the 1930s. At a time when farming was shifting from horse-drawn equipment to mechanization, Caterpillar recognized the need for compact, maneuverable machines that could operate effectively in tight orchard rows without damaging trees or fruit. The Citrus 22 was based on the proven Caterpillar 22 model, but modified for orchard use, with lower profiles and protective features to suit the unique environment. Equipped with a 4-cylinder gasoline engine producing around 22 drawbar horsepower, the Citrus 22 delivered reliable performance for cultivating, mowing, spraying, and hauling within orchards. Its crawler tracks provided excellent traction on soft or uneven ground, reducing soil compaction compared to wheeled tractors. Caterpillar engineers fitted the tractor with rounded fenders, a streamlined hood, and orchard guards to prevent branches from snagging or being broken during operation. Features that made it highly practical for fruit growers. The 1936 model embodied Caterpillar's reputation for durability and simplicity. Its rugged construction, easy maintenance, and adaptability made it a favorite among growers who needed dependable machinery to improve efficiency. While larger Caterpillar tractors were built for construction and heavy farming, the Citrus 22 represented Caterpillar's attention to specialized agricultural markets. The Zetor 25A tractor, produced in Czechoslovakia from 1946 to 1961, was powered by a simple yet robust two-cylinder, four-stroke diesel engine. With a displacement of 2.7 liters, it delivered around 22 horsepower at 1/800 revolutions per minute. The engine featured direct injection, water cooling, and a decompression system for easier starting, often aided by a crank handle or external heater in cold weather. Known for its low fuel consumption and easy maintenance, the engine could run reliably on poor quality diesel. Its durability and simplicity made the Zetor 25A a trusted workhorse for farmers across Europe during the post-war period. The Zetor 4718 was a popular tractor model in Ireland during the 1970s and 1980s, valued for its reliability, affordability, and straightforward engineering. Produced by Zetor in Czechoslovakia, the 4718 featured around 45 horsepower, making it well suited to small and medium-sized Irish farms. Farmers appreciated its robust design, easy maintenance, and fuel efficiency, especially compared to more expensive Western brands. In Ireland, the tractor became a common sight on mixed farms, handling tasks like plowing, mowing, and transport work. Today, the Zetor 4718 holds nostalgic value among collectors and vintage enthusiasts, symbolizing a practical era in Irish agriculture. The Deutz BF6L913E engine, rated at 134 kilowatts, G at 2,100 revolutions per minute, is a robust six-cylinder diesel engine widely used in industrial and generator applications. During startup, the distinctive deep growl of the engine quickly stabilizes into a smooth rhythm, signaling its reliable German engineering. Oil pressure builds up swiftly, ensuring proper lubrication of all moving components and confirming healthy operation. At MAN D2676, motor tests are carried out to monitor startup behavior, sound, and vital parameters like oil pressure, guaranteeing optimal performance and durability. This rigorous process ensures the engine is ready for demanding service. The Magirus Deutz BF6L913 is a robust, air-cooled, six-cylinder diesel engine widely recognized for its durability and efficiency. Belonging to the Deutz 913 series, it features direct fuel injection and a displacement of 6.128 liters, delivering reliable power output in the range of 168 to 190 horsepower, depending on configuration. Its air cooling system eliminates the need for radiators and liquid cooling, making it particularly suitable for heavy-duty applications in hot and challenging environments. The BF6L913 is commonly used in trucks, construction machinery, agricultural equipment, and stationary power units. Known for its long service life, ease of maintenance, and fuel economy, this engine remains a trusted choice for operators requiring consistent performance under demanding conditions. In 1930, the Water Department of Geneseo, Illinois, purchased a massive two-cycle engine that remains an impressive piece of industrial engineering. Built with a bore and stroke measuring 14 1/8 inches by 17 inches, the engine displaces a remarkable 2,700 cubic inches. Despite its size, it runs at a top speed of only 257 revolutions per minute, a slow but powerful rhythm designed for steady, reliable operation. The piston and connecting rod assembly alone weighs 1,000 pounds, emphasizing the scale of its construction. Its immense flywheel, 7 feet in diameter and tipping the scales at 500 pounds, stores and releases energy to keep the machine turning smoothly. Together with its starting system, the engine weighs more than 12 tons. Beyond its sheer size and weight, this engine represents an era when durability and raw mechanical power were the backbone of essential municipal services like water supply. The FAMOS engine, developed in Yugoslavia, was a rugged diesel power plant widely used in military and industrial applications. One of its most notable roles was in the GJ800 artillery tractor, a heavy-duty vehicle designed to tow large-caliber guns and provide reliable mobility over rough terrain. The first startup of the FAMOS engine in this context was both a mechanical milestone and a testament to engineering precision. When the engine was first primed, mechanics ensured that fuel lines were properly bled, lubrication oil had circulated, and cooling systems were ready to handle the initial load. As the starter engaged, the characteristic rumble of the inline diesel signaled ignition. At first, the engine sputtered with uneven rhythm, typical for a large diesel during cold startup. Within moments, however, its cylinders synchronized, producing a steady, resonant thrum that echoed through the test yard. Observers noted the absence of excessive vibration, a sign of balanced assembly, and the deep exhaust note that hinted at the engine's torque-rich performance. For the GJ800, this startup meant more than just power on wheels. It was the beginning of dependable service in demanding field conditions, where the reliability of the FAMOS engine would be tested under the weight of artillery and the rigors of military operations. The T800, equipped with a Cummins ISX engine, makes for an impressive combination of rugged durability and modern diesel power. On a first start, the process highlights the truck's blend of reliability and advanced engineering. After a thorough pre-trip inspection, checking fluids, air pressure, and electrical connections, the ISX comes alive with a deep, steady rumble. The engine's electronic fuel system ensures smooth firing, while the variable geometry turbo responds quickly, building power even at idle. For many operators, hearing that first start signals confidence that the T800 is ready to tackle heavy loads and long hauls. Known for its tough chassis and driver-friendly cab, the T800 paired with the ISX delivers both strength and efficiency. That first ignition is more than just routine. It's the start of a machine built to handle demanding jobs day after day, with the trusted performance Cummins and Kenworth are known for. The 1947 Kenworth 923 is a legendary piece of American trucking history, often admired for its rugged construction and no-nonsense design that laid the foundation for modern heavy-haul rigs. Built just after World War II, the 923 embodied Kenworth's reputation for durability, with a handcrafted cab, stout frame rails, and a focus on functionality over frills. Unlike the more streamlined trucks that came later, the 923 carried a raw, industrial look, tall stance, squared fenders, and exposed rivets, that symbolized the grit of post-war freight hauling. What made this truck especially notable was its power plant, the Cummins MAH714, nicknamed the Iron Lung. This straight-six diesel engine earned its moniker for its distinctive sound and ability to breathe deep under heavy loads. Rated at around 275 horsepower, the MAH714 was a powerhouse for its era, giving long-haul drivers the torque needed to conquer mountain passes and endure grueling coast-to-coast runs. The combination of the Kenworth 923's robust chassis and the Cummins Iron Lung created a truck that could handle oversized loads and punishing conditions that would sideline lesser machines. For many old-school truckers, the 1947 Kenworth 923, with its NH275, wasn't just a work tool, it was a badge of honor. These rigs demanded skill, patience, and strength to operate, with unsynchronized gearboxes and minimal creature comforts. Today, surviving examples are prized by collectors and restorers, representing a golden age of American trucking, when trucks were built to last and the road was still wide open. The Gardner 8 LXB diesel engine is a renowned inline 8-cylinder power unit producing 240 HP. Celebrated for its durability, fuel efficiency, and smooth performance, it was widely used in marine vessels, heavy vehicles, and industrial applications. Introduced in the mid-20th century, the 8 LXB became an engineering benchmark thanks to its robust construction and long service life. Even decades later, enthusiasts and operators value it for reliability, economical operation, and timeless mechanical excellence. The 1,000 horsepower directly reversible industrial diesel engine, built in 1956, represents a significant milestone in the evolution of heavy-duty power machinery during the mid-20th century. At the time, industries such as shipping, power generation, and large-scale manufacturing demanded engines that could deliver reliable performance under continuous, demanding workloads. This engine was designed to meet those needs while incorporating advanced features for its era. One of its most notable characteristics was its directly reversible capability. Unlike conventional diesel engines, which required a separate gearbox or reversing mechanism, this unit was engineered to reverse its direction of rotation by altering the timing of fuel injection and valve operation. This made it especially useful in marine applications, where quick and reliable reversal was essential for maneuvering large vessels in tight harbors or emergency situations. By eliminating additional mechanical reversing gear, the engine reduced overall complexity and increased efficiency. With a rating of 1,000 horsepower, the engine was among the higher output industrial diesels of its day, suitable for powering medium-sized ships, dredgers, locomotives, and even stationary power plants. Built in 1956, it reflected post-war advancements in metallurgy, machining, and fuel injection technology. The design emphasized durability, heavy cast-iron construction, robust crankshafts, and efficient cooling and lubrication systems that allowed it to operate continuously for extended periods. Fuel efficiency was also a key consideration. The engine's slow speed operation, coupled with its large displacement, allowed it to deliver impressive torque while consuming relatively less fuel compared to earlier models. Its adaptability and reliability made it a popular choice in regions investing in industrial expansion during the 1950s. Today, surviving examples of the 1000 HP directly reversible diesel are considered historical artifacts, representing an era when industrial machinery was built with uncompromising strength and practicality. They stand as reminders of engineering ingenuity at a time when diesel power was reshaping global transportation and industry. The Pyina GT027 turbine generator is a compact gas turbine engine developed in Germany, primarily designed for use in aerospace and power generation applications. It delivers a reliable source of mechanical power by converting energy from high-temperature gases into rotational motion. Known for its lightweight design and efficient performance, the GT027 has been applied in auxiliary power units, APUs, small aircraft propulsion, and portable energy solutions. Its modular structure allows easier maintenance and adaptability across different platforms. With advanced engineering, the turbine generator offers a balance between durability, fuel efficiency, and performance, making it suitable for both civil and military applications. The Pyina GT027 reflects precision German engineering, offering dependable operation in demanding environments.
About 30 pounds.
The 1881 Westinghouse traction engine was a notable step in the evolution of steam-powered agricultural machinery during the late 19th century. Developed by the Westinghouse Company, better known for its work in electrical engineering and railroads, this traction engine reflected the era's growing demand for mechanized farming and transport solutions. Unlike stationary steam engines, traction engines were mobile, self-propelled machines capable of pulling loads and powering farm equipment through a belt drive. The Westinghouse traction engine of 1881 was compact, efficient, and designed with farmers in mind. It featured a vertical boiler, a departure from the more common horizontal types, which allowed for a lighter and more maneuverable build. This design made it easier to operate in fields and on rural roads. The engine could be used for threshing, sawing, and hauling, replacing teams of horses and reducing the labor required for large agricultural tasks. Westinghouse traction engines earned a reputation for reliability and safety, aided by the company's innovative boiler and valve technology. Although they were eventually overshadowed by the rise of internal combustion tractors in the early 20th century, the 1881 model stands as an important milestone in the transition from animal to mechanical power in farming.
So we need to retard it more?
They're all beat up.
They're all running good now. No leaks, no drips, no errors.
It has life.
The Holt 120 engine was a significant development in the early 20th century. Designed and manufactured by the Holt Manufacturing Company, a pioneer in heavy machinery and track-type tractors. Introduced during the 1910s, the Holt 120 was a 4-cylinder gasoline engine, rated at 120 horsepower, a remarkable output for its time. It was primarily developed to power large Holt tractors used in agriculture, logging, and construction, as well as military applications during World War I.
Rev it up a little.
The engine featured a water cooling system, large displacement cylinders, and robust cast iron construction to withstand heavy workloads. Its power made it suitable for pulling plows, towing artillery, and handling industrial transport tasks, where smaller engines proved insufficient. The Holt 120 was also reliable under difficult conditions, earning a reputation for durability and efficiency. One of its most important roles came during the war, when Holt tractors powered by the 120 engine were employed by the U.S. Army and Allies to tow heavy artillery across muddy, rough terrain where horses and traditional vehicles failed. This demonstrated the practical military value of mechanized engines and foreshadowed the rise of modern tracked vehicles, including tanks. The Holt 120 engine thus holds an important place in both agricultural and military history. The 1917 Holt 120 tractor was a groundbreaking machine that played a pivotal role in both agriculture and military history. Manufactured by the Holt Manufacturing Company, it was powered by a 120 horsepower engine and built with continuous tracks, a technology that inspired modern tanks. Originally designed to replace horses for heavy farm work, the tractor's rugged design and track system made it invaluable during World War I, where it hauled artillery and supplies across muddy, uneven terrain. Its reliability in harsh conditions demonstrated the potential of tracked vehicles, influencing military engineers worldwide. Beyond the battlefield, the Holt 120 helped revolutionize farming and construction, reducing dependence on animal labor and paving the way for modern mechanized equipment. The Deutz MIH436 is a robust stationary diesel engine designed for industrial and agricultural applications. Built by Deutz, a renowned German manufacturer, it features reliable air cooling technology, ensuring durability and efficient operation under heavy loads. With its compact design and sturdy construction, the MIH436 was widely used to power generators, pumps, and machinery. Its reputation for longevity and low maintenance made it a trusted choice in demanding environments worldwide. The Deutz F6L912 is a robust, air-cooled, six-cylinder diesel engine widely used in industrial, agricultural, and construction applications. Known for its simplicity and reliability, it features direct fuel injection and a durable design that minimizes maintenance requirements. Its air-cooled system eliminates the need for radiators and coolant, making it ideal for harsh environments where liquid cooling may fail. Compact and fuel efficient, the F6L912 delivers consistent power output while withstanding heavy loads and extreme conditions. This engine is often found in generators, compressors, trucks, and heavy machinery, valued for its longevity, ease of service, and dependable performance worldwide. The W51 was a four-cylinder, water-cooled diesel engine built with a cast-iron block and head for strength and durability. It employed direct fuel injection, delivering excellent fuel economy and high torque at low revolutions, qualities that made it especially reliable for heavy-duty work. When paired with a water pump, the engine could maintain stable operating temperatures even under continuous loads, an important feature for transport vehicles on long hauls or for machinery running in demanding environments. This engine was not only installed in commercial vehicles such as lorries and buses, but also found use in stationary applications, including irrigation systems, industrial pumps, and generators. In agricultural settings, the W51 with water pump became a trusted power source for driving equipment and managing water supplies, critical for farming in post-war France. Operators valued the W51 for its ruggedness, simple maintenance, and adaptability. Though Bernard Motors eventually faded from prominence as global manufacturers gained ground, the W51 diesel engine with water pump remains remembered as a practical and hard-working machine that embodied the reliability and resourcefulness of mid-20th century French engineering. The 6 HP Ingo stationary engine was a reliable hit-and-miss style engine built in the early 1900s by international gas engine company Ingo of Cudahy, Wisconsin. Designed for farm and industrial use, it delivered steady power for tasks such as pumping water, running saws, grinders, or small machinery. The 6-horsepower model typically ran on gasoline or kerosene and was built with a heavy cast-iron frame, large flywheels, and a simple ignition system, ensuring durability and ease of maintenance. Known for efficiency, the hit-and-miss governor allowed the engine to fire only when needed, conserving fuel. Today, collectors and restorers value the 6 HP Ingo for its rugged construction, distinctive sound, and role in early 20th century mechanization. The Benz patent Motorwagen, built in 1886 by German engineer Carl Benz, is widely recognized as the world's first true automobile powered by an internal combustion engine. Unlike earlier experimental vehicles, which were often steam-driven or adaptations of horse carriages, Benz's Motorwagen was purpose-built as a motorized vehicle, marking the beginning of the modern car industry.
I'd hate to be trying to go to the movies or something like that, really.
You'd have to leave early.
Yeah.
Well,
The Motorwagen was a 3-wheeled vehicle with 2 large wheels at the rear and a smaller steerable wheel at the front. It was powered by a single-cylinder, 4-stroke engine producing about 0.75 horsepower at 400 revolutions per minute. Despite its modest output, the vehicle could reach speeds of up to 16 kilometers per hour, 10 miles per hour, which was remarkable for the time. The lightweight tubular steel frame and wooden-spoked wheels gave it both strength and maneuverability.
This isn't hit and miss. This is a fire every time, right? Yeah, it fires every time. There you go. He's done this in a lot of cars I've seen. You kidding?
Carl Benz patented the Motorwagen on January 29, 1886, under German patent number 37435, officially making it the first patented automobile. However, the invention faced skepticism initially, as many doubted the practicality of a self-propelled vehicle. Its true potential was demonstrated in 1888, when Bertha Benz, Carl's wife, undertook the first long-distance journey by car, driving about 66 miles, 106 kilometers, to her mother's house. This historic trip not only proved the reliability of the Motorwagen, but also highlighted the future usefulness of automobiles in everyday life. Today, the Benz Motorwagen is celebrated as a groundbreaking innovation that paved the way for the global automobile industry, transforming human mobility forever. In 2019, Haka, Sweden, hosted a gathering dedicated to hot bulb engines, a fascinating piece of industrial history. These engines, often called tandkulamotorer in Swedish, were once widely used in agriculture, fishing, and small-scale industry throughout the early 20th century. Their distinctive operation relied on a heated bulb to ignite the fuel, producing a slow, rhythmic chugging sound that remains iconic among enthusiasts. The Haka's event brought together collectors, engineers, and curious visitors to see restored engines in action. Many of the machines on display were over 80 years old, lovingly maintained, and still running smoothly despite their age. The atmosphere was filled with the smell of oil, the sound of heavy pistons, and the sight of massive flywheels turning steadily. More than just a mechanical showcase, the gathering served as a cultural celebration, keeping alive the memory of a technology that powered rural life long before modern engines became the norm. Motorul Deutz BF6L913T, CU o putere de 130 cp turboalimentare, este un motor diesel robust utilizat frecvent in applicații agricole și industriale. În cadrul testului de pornire TAF realizat de Matadotti SRL, motorul a demonstrat performante remarcabile, pornind ușor chiar și la temperaturi scăzute. Acest test evidențiază fiabilitatea și eficiența motorului Deutz, fiind o alegere excelentă pentru echipamentele care necesită putere constantă și durabilitate. The Atlas Copco PRH700DD is a robust, portable diesel air compressor renowned for its reliability in demanding applications such as mining, construction, and industrial operations. At its core, it is powered by the Deutz F12L413, a 12-cylinder, air-cooled, 4-stroke diesel engine. This engine configuration ensures high torque at low speeds, making it particularly suitable for heavy-duty tasks. The PRH700DD delivers an impressive free air delivery FAD of 700 CFM, approximately 20 cubic meters per minute, at a working pressure of 10.5 bars, 150 psi. This capacity allows it to efficiently power pneumatic tools, assist in drilling operations, and support other high-demand equipment. The combination of the Deutz engine's durability and the compressor's performance makes the PRH700DD a preferred choice for professionals requiring consistent and powerful air supply in challenging environments. The Deutz MAH714 is a robust diesel engine, widely recognized for its reliability and efficiency in industrial and agricultural applications. When paired with a 5.5 kVA generator, it becomes an effective power solution for small to medium-scale electrical needs. Performing a load test on this setup is essential to evaluate its performance, ensure safety, and confirm that it meets the expected power output under varying conditions. A load test involves running the generator at different load levels, from no load up to its maximum rated capacity of 5.5 kVA. This process helps in identifying the engine's stability, fuel consumption patterns, and efficiency. During the test, critical parameters such as voltage, current, frequency, and engine temperature are monitored. Observing these factors ensures that the generator delivers a stable output without overheating or overloading the engine. For the Deutz MAH714, the test typically begins with a no-load run to warm up the engine and stabilize the system. Gradually, resistive or inductive loads are applied to simulate real-world demand. The generator's response to sudden load changes is also checked, as this reflects its reliability during unexpected power fluctuations. Fuel efficiency is measured throughout the test to determine operating costs and optimize usage. Conducting a load test also allows for the early detection of potential issues, such as voltage drops, frequency instability, or mechanical stress. Proper documentation of the results helps operators schedule maintenance, prevent downtime, and extend the life of both the engine and the generator.